Okay, now we're going to get to the real notes. So we'll try this again. So today's lesson is on solving square root equations. So we're going to start moving towards using the Inspire calculator more. So as I'm learning how to use it, I'm going to share with you. So to turn the Inspire on, we're going to press the on button. Okay, and we're going to go ahead and click on OK. So we press this button in the middle. At least that's how I do it. And we want to open up a new document. This is the way I do this. And then we want to delete any unsaved documents. So I'm going to click on No. Okay, so at this point we can use the calculator option or we can use the graphs. So for what we're doing right now, I'm going to go ahead and just use the calculator option. So there's our calculator screen right there. Okay, so let's go to this first example. So when solving a square root equation, one of the key things, you want to make sure that the square root, the radical, is all by itself. Okay, there's no vertical things happening here on the outside. We just have the radical by itself. Okay, so we want to solve for x. So remember, to solve, we have to undo the operations. So we work PEMDAS backwards. Or I should say GEMDAS for grouping symbol, because obviously our grouping symbol is not a parentheses here. So GEMDAS. So we undo adding and subtracting. Okay. There is some, but it's inside the grouping symbol. Okay, so we're going to move all the way up here. We're going to undo the exponent. Okay, the exponent. Now the exponent square root, guys, it is an exponent. Okay, this right here, if I wrote it exponentially, it would look like this. Square root is the 1/2 power. I want you to memorize that. The numerator represents the power and the denominator represents the root. So if this had been a third root, if there was a 3 in here, it'd be 1/3. Okay, so to cancel out a square root, we basically square it. So what you do to one side, you do to the other side. So the square root cancels out, the square cancels out the square root. So we're left with x plus 3 equals 4. And simple finish, we get x equals 1. Now you can plug this in and see if your answer is right. 1 plus 3 is 4. The square root of 4 is 2. Easy check. Okay, let's take a look at number 2. So notice my radical is not by itself. We have a negative on the front and we have a 5. So we need to get rid of this first. So the first thing we do is we undo any adding and subtracting. So we're going to get rid of the 5 by subtracting it. Okay, then we get rid of the negative 1 on the front by dividing it, because this is multiplication. Okay, so we have the square root of x plus 1 equals negative 1. And then we're going to go, now we're back to just like example number 1. We're going to square both sides. And we're going to subtract 1, x equals 0. Plug it in. 0 plus 1 is 1. The square root of 1 is plus or minus 1. Got to be careful here, because when you take the square root, it's both positive and negative. Okay? So if we use the negative 1, we get 5 minus negative 1 is 6. So that is the solution. All right. The other solution, if we had used the positive 1, we get 5 minus 1 is 4. That would be known as an extraneous solution. It does not work. Okay? It does not work. Number 3. Notice we have two radicals. Very important. They need to be on separate sides of the equal sign. Okay? They can't be on the same side. They have to be on separate sides. And you would move them by adding them or subtracting them. That's how you would move them from one side to the other. So, real simple. We're going to square both sides. Because the square cancels out the square root. And we're solving for x. We got an x on both sides, so we have to cancel 1. And we just have a two-step equation. Add 4, divide by 4. So we're going to have 14 divided by 4. So x equals, simplifying that, we get 7/2 as our solution. Okay, let's take a look at number 4. Now notice the main rule that I started off with. The radical needs to be alone. Okay? So the radical is not alone. It's got an x with it. So just to show you how to move a radical, I think what I'm going to do is move the radical over here and move the 3 over here. Now, I know what you're thinking. Well, Mr. Kramer, why don't you just move the x over? Yes, that would be the easy way to do this. But I just want to show how to move a radical. So since this is a positive square root of x minus 1, if I want to cancel it, I can subtract the square root of x minus 1. What you do to one side, you do to the other side. Oops. So now what we have here is we have x equals 3 minus the square root of x minus 1. Now I'm going to subtract the 3. We get x minus 3 equals negative square root of x minus 1. Now I want to say something. I misspoke earlier. When I told you that the radical needs to be alone, nothing on the outside, well, if it's something that's being multiplied, okay, it doesn't have to go away. Okay, if it's something that's being added or subtracted, it definitely has to go away. What do I mean? Well, let's say that I don't get rid of this negative 1 on the front. And we just go to squaring both sides. Okay? Well, so we're going to do x minus 3 squared, which I know you're going to come up to me and you're going to say, how did you do that? How did you go from here to here? Well, you should know how we do that by now. We took x minus 3 times x minus 3. Okay? Anyway, and then here I'm going to square the negative 1 first. If I square a negative 1, I get positive 1. Yay! And then if I square this, the square root goes away. So I squared the negative 1, I get positive 1. I square the square root, they cancel. Alright, so what we have now is a quadratic. So I'm going to go ahead and set it equal to 0 because we know that that's what you're supposed to do when solving a quadratic. And then let's try to solve this by factoring. See if that works. 10 on top, negative 7 on the bottom. Looks like negative 5 and negative 2 will do the trick. And so we get x minus 5 and x minus 2. Now we're going to set each factor equal to 0. We're going to get x equals 5 and x equals 2. Now here's where we need to just make sure that both of them work. So let's plug 5 in. 5 minus 1 is 4. The square root of 4 is 2. So we're going to have 2 plus 5 is 7. Does that equal 3? No. Let's try this one. That's extraneous. Does not work. 2. 2 minus 1 is 1. The square root of 1 is 1. 1 plus 2 is 3. Bingo. That's the answer we want. All right, I'll see you in class on Monday.